Okay, so with the modern day timing, what actually the modern definition of ML mostly stands for, it is from a definition of 1990. If a particular, there is some task T and a performance measurement of P. So a performance measurement, why it is needed? Because as a human, maybe when I do some job, Suman, it's 70% correct. Or there is someone who can say, Suman, it's not perfect. You can do this part bit of here and there, and it will be perfect. So we all measure our task. Everything that is quantifiable is defined as a task, or that is called the measurement. So after a task T, and if we can measure some performance P, depending upon my experience, if my experience automatically improves, then it is the formal definition of ML as they stated. Okay. So hopefully anything from this slide want to ask me right about ML definition and how they're defined? Okay. So I try to make it as interactive as possible. Hopefully I won't bore you, everyone. Okay. So coming on to the ML's classification, there are lots of classification, and some people may not agree with me. There are different data practitioners. There are different views, because when this subject is developed, there is no particular line that this field is this one and this is just this. There may be some scenarios where it is overlapping. So basically in the next slide I will let you see that there is some conjunction which is combination of everything. So mainly there are three categories: supervised, unsupervised, and reinforcement. Anyone can Google it and read the definition, but it's not my job to just state another definition, because there's no point. Anyone can read a book. My point is to make it as simple as that. So coming on to the supervised learning, say I'm a novice guy. Okay, I ran into a job. Someone's telling me that I'm doing some task, and there is my supervisor telling me, no, Suman, it's not perfect. Just do much, that much, do this, that, and he or she is guiding me to do a certain goal or to reach a certain goal. Then we can say it as supervised learning. So there are some, as we call it, or we have gone through so many, like training. We train machine. So training is kind of, you can say, supervision. Supervision is nothing but someone is guiding me. Okay, Shuman, this much and that much, and it will be perfect. So there is someone who will guide me on the agenda, how much my process is on the scale of perfectness. So there are some levels. So that is mainly supervised. And in unsupervised, okay, the best example I have ever gone through on an unsupervised is about, say, kid. I bring a kid who just know colors. I give him some papers. Okay. And I some colored papers. Say three, one is red, green, and some blue papers. And I tell him to automatically just put the red papers in the red box, blue paper in the blue box, and green one in the green box. So how does he do it? If we have we ever thought of it? He actually, the red color gives us the sensation, is the same sensation the red box gives us, right? So there is no one we need to tell us that this is similar. So you automatically sense it. So that is the fundamental idea, how we teach our machine for unsupervised. Now you say me, how can a kid can get a sensation? How the machine can get a sensation? There are certain terms, if anyone is interested, obviously can Google, or we also read in geometry. Euclidean distance, we have heard of. Some of us, I also forgot in back of the some days, but let me just give an introduction. Okay, we see a very fine thing in nature, that is, in this office, I bond with everyone, but exactly when I go for the tea, I tend to mix with my similarity age. Why? Because I am drawn towards that kind of thing. It is not, nobody has told me that go with this group or go with that group. Whenever we give a small adda of our own, we always try to find our own cluster. So there is no one who is supervising us, but we find similarity. And this similarity in geometry, it is measured in distance parameters. And there are different distance parameters we can see. Okay, and coming on to the reinforcement learning. The reinforcement learning, the first example or the second one that I gave today, a kid touches a hot surface, his palm gets burned. So that is kind of reinforcement. What is that? Say, if today I upload a code on GitHub and Office award me something. So that is what? That is a reward point for me. Next time we will try to bring 2 codes to the GitHub. That is reinforcement learning. So whenever we treat a machine, if it does a good job, we add some bonus point it, or we will say you have done a good job. In there are certain respect. I'm not going into the mathematical detail, but there can I go and for the sessions if I get a chance and if everyone is not bored. Okay, so if I go for that, if there are certain things added, reward points, then it will try to repeat those kind of tasks. And suppose it does a wrong one and it gets some scolding from someone, then he tries to not do it. So that is kind of the idea of reinforcement learning. So some task, as they say, or they call, this is a mixture of these 3 also can be done. Okay. Anyone, any question? Okay, hopefully I'm not boring. Okay, so coming on to the supervised learning, the most famous example that we always been taught whenever we learn ML. This is a famous problem of very old. This problem is actually known as house price prediction problem. Very famous one. Whoever just gone through any ML book, it will be there. So I know it may sound a bit mathematical, but it's not. So I can say there is some features. So what is feature? As some who has already seen me or who has not seen me, as a human, what features do I hold? It is under normal circumstances, I will have 2 hands, 2 legs. These are my features. So in case of this office, so what is the feature? Length, height, breadth. These are the, we can call these features, nothing else. So here X1 represents a say certain area of this. So whenever we go to purchase a house, we always ask for what is the carpet area, right? So X1 you can represent of as like a carpet area, and Y1 represents its corresponding price. So what I have done is there is a graph which is saying what is the price. Say there is a 500 square feet flat. For a 500 square feet flat, the price range. Okay, by the way, so this price range, if I get a flat at this price, I will right now buy it. So don't go for the point figures. It's what I do. This is called feature scaling. So what is feature scaling? Suppose, say, on a mathematical dimension, what is mathematical dimension? I will come into the latter part. Okay, so if everyone is given 100 rupees, 200 rupees, or 10 rupees, 20 rupees, mathematically it's same. Because if I think of the magnitude, if someone gets 200 rupees, I get 100 rupees. I'm half of him. I get half paid of him. In the same way, if someone getting 20 rupees, I'm getting 10 rupees. It is same, right? On magnitude. Do not think of it like a face value. Think of on the magnitude term. Okay. So if I can think of that, so now why we do not go for 100 and 200, or why did not I put lakhs here? Because if I would have put lakhs here, the computation will get more and more burdenful. As we know, what is the limitation? My hardware is a limitation. We always work in a certain amount of GPU. We always try to perform our best in the limited resources. So in order not to waste resources, we do not need to say if figures are all in the range of lakhs. So I need to capture the magnitude. So I just brought them down to the magnitude level. Okay. So that's why these prices are on the point. So for a 500 square feet flat, if I say my prices are pointed like this. So this is this represents my flat size and corresponding price. So as we can see, these are the some data that has been recorded over the year by say some firm, some corporate, say some forms of real estate. Okay, now they asked me whether they will hold a property for long or should they sell it, or maybe it's a very common thing to us. Whenever there is a metro station walk is going, flat at the neighbor region gets higher. Why? Because we already know if the metro is there, the time will be taken less. So that special feature has been added. the price will go up. Now, if I today open a newspaper and get a news that tomorrow some minister has decided to lay a stone for a metro, and I fortunate enough by me, I hold a flat there. So should I sell it? No. Everyone will say, Suman, hold it for 5 years if you have capacity, and then sell it. So for say some uh, so for x of 15 means the 15th feature, this x on top of this suffix, this represents the corresponding price, the corresponding index. Now, if I try to fit a line here, so there can be two possible lines, right? So this one yellow line and one is red line. These two lines can fit the data, right? This point, if I say, I do not have to know how straight line is fitted. If I just give some dot points, and if I say anyone, try to draw a line by taking as many dots in the line as possible. There can be, on the best fit line, there can be these two lines. So depending upon, if someone asks me, say, Suman, I have a 800 square feet flat. So what will be my price? So in that terms scenario, where can this point lie in the yellow line or the red line that represents my predicted price? Okay. So this is mainly the idea of supervised learning. Okay. Now this is one feature. So say I have more features. What do I mean by more features? So I only had the idea there is some square feet of area, and on the square feet of the area, there are certain price. And with the not just square feet, I tends to add the lot size. Or maybe if lot size is okay, we all want to live in an area or neighborhood where there is less crime. So there is, say, another parameter, the crime rate of the city. So we all want to live in a city where crime rate is less. So this represents, so if I can think of it in a three-dimensional figure, we can represent one particular dimension for one of the feature. So instead of a 2D diagram, it becomes 3D, 4D. I know up to 3D imagination is good. But when we go to the higher dimension, say 4D, 5D, n dimensional, it is imaginarily, it's difficult, but on a vector space or maybe on a space of mathematics, we can do it. And it is our goal to take it to that feature space and predict the price. Okay, so there is lots of feature we can represent as. So these are the different features I have tried to explain. One of the feature can be living size, lot size, number of floor, condition, zip code. So this structure, the kind of, we can think of it as a matrix, right? We all heard of matrix. So, or a list of numbers. So the list of numbers is being called the feature space of feature dimension. Okay. So there is a buzzword also, neural network. We also use this kind of feature space in our neural networks. Okay. So mainly on the supervised learning, there are two types of problem, or in general, any problem is of two types. Suppose there is some kind of question where answer can be given in yes or no, or in some categorical features. So will it be rain today? Answer can be given yes or no. Or maybe. So I can say 0, 1, 2. But the problem we have discussed earlier, which is the price of the house, we cannot say it's a 0 or 1. I have to give a real value number. Say 50 lakh, 20 lakh, 22 lakh. So this range of number is so many. So there are any problem can be discussed in two ways. One is regression, another is classification. Okay, so regression-based problems basically deals with the idea where we have to predict a real valued number, not in the discrete range. And classification problem tends to give us the answer where the price is being predicted between some certain range of values. So both are this kind of problem. So whenever we try to predict a line and predict the corresponding size, this becomes a problem of regression. Whereas in this problem, the picture I'm seeing in the screen, it is basically of two types. Say I have been given some picture of a house. Now someone asked me whether it's a city house or a town house. So if we go into a big town, we see in our city house, it is mostly, there are no gardens. And mostly there are no open spaces. But in case of townhouses, there are these features. So depending upon features, just given a picture of house, if someone asks me whether it's a city house or town house, so that becomes a classification problem. The same problem can be stated as. Okay, so coming on to the supervised learning in computer vision, how do we do it? Okay, so whatever picture we see in our life, whatever picture in screen, this is consist of three things. Uh, Matrix of red, green, and blue. Any pixel can show these three colors, and this intensity varies between 0 to 255. Okay, so basically it's just 8 bits are used, so that's why 0 to 255. Okay, so basically, if I say given us some 0 to 255 matrix to me, and what is my objective? I want to detect the main object of the feature. In back of when I was a bit kid, like in college, we used to fancy a feature of Facebook. If we upload a photo, it detects our face, right? And we can tag that person. This is XYZ, this is ABC, and that person is correspondingly. We are so fascinated by the. Now, the same problem I am stating, I have given some picture. My main idea is to recognize a particular object, which is the center object. Because we all know, as a human, if I give anyone of this picture, so what is the main, who is the primary focus of this picture? Anyone of human can tell. But how a machine can tell? Because machine is seeing only the pixel values of 0 to 255. So that is kind of one of the supervised learning. Because if I let it see the main intensity for some pictures, like Sumanda already have done this kind of job once. He has cropped these pictures and tell the machine, in our GEOGO, there is a project going on image detection, image digit detection. In the same way, this training has been done, the main objects are being classified and box has been drawn. From those boxes, actually machine learns how to classify the main object. Okay. And there is another set of things we really admire, that is translation. We all use, somewhere or down the line, we all used Google Translate. In the Google Translate, what we have done is basically, it may represent very surprising how it can be supervised. But let me tell you one thing. When Google Translate used to do this, we all used, Google is a very clever company, very much. Why? We all used Google Photos, right? Or some of us, most of us. We are so fascinated that Google Photos is giving us unlimited storage. But in machine learning or in computer science or in real life, I tell you one thing that I have seen everywhere. There is no free lunch. We call it very important theory. So when Google is giving you those images, because they have designed a big actually deep neural network, which requires regressive training. But those data are not available ready-made. So what they do, they put us in a, they have lots of storage. So what they did, they alloofed us that you go store in my Google Photos, those photos, I will train my network. And when my network is ready, they throw us, now you have 15 GB. So in the same way, we all need training. Now, why I discuss this? This supervised learning, when Google Translate used to do this, what they did, it's a, as far as I've read, it's a Stanford MIT combined project it was started. So when it started, basically, we all read dictionaries. For a one word, there are lots of synonyms. Okay. Now, I hopefully whoever has joined meeting understood Bengali, or if not, pardon me. There is a word, ami bhat khabo. I say, ami bhat khabo. So bhat means rice. So bhat is interpreted in English as rice. So bhat is rice. There can be synonyms of bhat in different languages. So what machine does, it does not know at first. It has been first, there are some stock of words, it's been trained. Now, when it made mistakes, actually there is an option, user can give feedback. From that, it automatically loads into his memory what are the corresponding meaning of that. And from those meaning, we can interpret future meanings where we can start exploring the emotions or the message behind it. Or we may be surprised how ChatGPT understands. It does not know. It follows the structure. What structure? Right now, normal English, how normal English are framed? It's just first I, we, this kind, followed by some pronoun or something, verb, and there comes adjective and those things. So there is a structure. We may not notice it very carefully, but there is a structure. One fine morning, you do an experiment with ChatGPT. Try to do a similar kind of questions to ChatGPT. Certainly take a 360-degree switch for the question, and most of the cases ChatGPT fails. Why? Because if it gets neural network trained like that, it is getting my history. What these kind of people. On a Google search, if you go to my Google and go to the search bar, I can let you see. Yeah, sure. If I go to Google and if I click this, so what is my things? It can show. So it's expecting me. Now, if I ask it some different question altogether, it will take some more time, because there actually always we humans trains to ask similar kind of things, and it is our natural habitat. So we, as a data science practitioner, has focused on this. So that's why this supervised learning of translation also is a problem of supervised learning. And next comes the unsupervised part. In the unsupervised learning, there are mostly what we can say the same problem I used to describe, where townhouse and normal house are classified in different colors or different shapes. Right now, someone pulls out this. Right now, someone just do not give me the left pick and give me only the right pick. Now, how do I understand it? How do I understand it? As if it appears, how can I understand it? But look, there's some patterns. In naked eye, normally we may not see it. But if we see Euclidean distance, we can see it. Or maybe this one. So this is what we do. We measure the distance between the points and try to group the similar kind of points together. This is mainly an idea of unsupervised learning. Okay, so maybe this does not make much sense to me, or maybe I'm boring some color. So I give you one good ray of hope, and my MTech project was on mainly this. We used to have this. What is this? We all know basic structure of us is DNA, right? And DNA is made of a protein, amino acid. So our gene, whoever is a healthy person, their DNA and genes basically, if we take a heat map, or this is actually called mRNA. If you Google it, there are some machines who measures it. How measures it? I also do not know, but we can get these pictures. Just look at these pictures. The left ones are the most healthy ones, and the red ones are the most actually someone who's suffering from cancer or some kind of terminal ill diseases. So look, automatically, maybe if I do just cover, or maybe who is seeing in the screen, if you cover this upper part, it may sound delusion. But look, if we try to cluster this, we can automatically detect who is a healthy person, who is an unhealthy person. Now, think of it in a very village or rural area where doctor is not that much available, or we also know in government hospitals or clinics, how, or like countries in India, it is not very much for a doctor, they always do overwork. I have seen. So if a machine is helping him, try to first detect the ill terminal disease patients, automatically will get the first priority. And who is on the priority list, they can sort it out, and machine can sort it for them. They do not have to go through each and every report, because it's wastage of their precious time. So this is the main idea where unsupervised learning comes into the picture. Now there are lots of mRNA features we can focus on, or if someone is identifying where this has taken from, I can share the PPT if someone wants. This is the in last there is the reference of the research papers from where it has started. Okay, now this is a maybe, hopefully I'm visible. This picture I got a bit blurred, but still I'm trying to justify my bet. The upper D0, D1, these are basically document numbers, and these are the words that appeared in those documents. And lighter means this air word is middle used, and the more lighter it gets, the less frequency it is, and the more deeper it is, the more frequently those word is found in the document. Okay, I think it's clear. Now, as if what this picture makes sense? Nothing. Okay, so hopefully everyone enjoys this video. Now, just look. If I do a permutation combination and arrange those words, just look a wonderful thing. Air, pollution, power, environmental, all grouped together. I have not touched it. This is done by a machine. Is this word related? Yes, definitely. Just look at it. Shuttle, space, launch, booster. Automatically it is talking about a space project. So those documents are corresponding to space project. So if I given thousands of documents and someone tells me, Suman, group these documents into one folder, we all go through this problem. We do not have to. Machine will do that for you. That is how unsupervised learning can be a beautiful thing. Okay. So, and how we also tag words for us. Basically, we for every word, say graph theory, logic, number theory, mathematical physics, or some those words, it's always linked to some particular topic. So this is how ChatGPT kind of maintains its own structure. And for whenever you search a new word, it always finds the tag where you want to store it. Okay, so what large language model do? I could have written ChatGPT and it will have lit up everyone's eyes. But still, I try to say the technical term ChatGPT is one of the LLM. There are lots of LLM is going on, and this is known as large language models. So large language model, actually how we are very fancy. We all want to know how ChatGPT works. In as simple as words, how ChatGPT works is basically it maintains a knowledge graph. So what is a knowledge graph? So it takes certain keywords and terms like say Barack Obama. We all know Barack Obama is a president of USA. By the way, I'm not affiliated to any political party, so nothing is a political anything. So Barack Obama is a politician of USA and some married to someone, and there are lots of connections. Now, as a human, we also do this in our brain, right? So this structure is actually maintained by the chat GPT. So whenever you search things, it is automatically takes all of its values and give you answer. And always, if you watch carefully in chat GPT, you say regenerate response. So it means that path is not very useful, that person. So go for another path. Maybe that path is feasible for you. So that's how basic chat GPT's intelligence works. And how we build it, this is lots of things, encoders and decoders. If everyone is interested, we may get a detailed session of how ChatGPT works. And this is how, if someone asks me, I always find myself in visiting everything and always try to see it in a novice eye. Why novice eye? Because someone asks me, what do you know, Suman? If some layman comes to me, tumi ki karo? Or what I do? I always say work in a company of salt. So there is, oh, okay, you know computer. For a layman, I know computer. Now, if to a computer expert person, what I do? Some say I will do web development. Some say I will do ML. Some say I will do this. But inside, just think of inside the web development. Some may be doing Node. Some may be doing React. Some may be Ruby. Some may be HTML. So if I go that level, the knowledge gets expanded. Okay. So depending upon that, our knowledge actually breaks down to a very final level. And we all master in our finite domains. But to a layman person, it may appear we know only computer, right? If someone asks us and come into this office, oh, you all guys know computer. Say he's an alien or she's an alien. Oh, you guys have a computer and all day you stuck. And to him or her, it may similar we all are stuck to a screen. But maybe we are not. We are doing different works of in the same computer. So that's how our knowledge level differs. Okay. So for LLM, so basic idea, this KG means knowledge graph. That picture I have showed you. Those from the knowledge graph, whenever you ask some question, this LLM means you can think of the chat GPT interface. You ask something, it goes to the fact what is knows from the knowledge graph, it retrieves it, What does this backpropagation means? Backpropagation means basically whenever you ask ChatGPT, it gives you the answer. Now you are not satisfied with the answer. Now you say regenerate. So it trains its network that, oh, there is some error. I am not good at it. So next time it goes with a better path. And if that path is suited by most of the user, then it automatically understand, oh, this knowledge is more useful. So that's how, if you have used ChatGPT some back of the days, it was not that good as right now. They have launched ChatGPT 3, 4. That means their training is now been done. Now you guys already trained its product. Now they are selling it to you because they are not publishing the free network to us only, but the paid one, which is really good trend, that has been kept for business. And as we know, to come to the reinforcement learning. So one of the automatic chess player in the USA, it is very famous. That is AlphaGo. So as I already told in the expression, it always collects the data from the environment, and from the data it has collected, it gets its awards, and based on awards, it actually knows whether this is a good one or a bad one. Okay, so hopefully right now it makes sense why these things clubs together. And some deep learning. On deep learning, this is a famous picture, or everyone has seen it. This nothing but actually these yellow ones are representing the features. We take the features, and there are lots of blue ones are the nothing but some kind of, you say, okay, I go to in this office or in some office, I go to a person, I tell him I read this book, and from this book, these are the points I have liked. And from those books or from those points, someone updates its knowledge. Maybe I have sent 10 words to him about the book, but he will like actually 2 or 3 points. It updates its memory, and next time it will try to use that. And from this entire lecture I have given, maybe someone will pick only 1 or 2 points that they mostly like, and they will cultivate on that. Our deep learning, these lines that are pointing, this is actually the same thing. This is why it is called a brain. It actually takes the path that is most suited for the job and automatically trains it. Okay, so I think for today, this much is enough. I don't know if I bored all. But hopefully. Any questions? Large language models. Okay. Okay, any question from online who have participated? Okay, Priyanka has left already.
Unsupervised learning has no level, so how they are useful?
How they are useful? Because most of the data are not, there is no one to supervise most of the data. In case, say the gene data, there is no one who is pointing that these are the ill-terminate patients. I just get the data.
So there is a level that you are.
No, suppose a person is not diagnosed till that point. Or say back of the some days later, there are used to be some the reports that has been computer is in latest part, but say in some cases the data have been recorded. Say I am a patient. For me, data has been recorded from 5 years. The tests are going on. And no one labeled me as a cancer data, or maybe the same diagnostic center I do not go anymore. So they do not know whether I am prone to any disease or not. But they have my blood report. They have my every details. Now, from a healthy person, and my blood report will automatically differ. So this is where basically comes into the pictures. And most of the cases, in this GEOGO only, I also worked in some cases where there is satellite images. Satellite images taken from up, or maybe some for a land acquisition. It is one of the work Suntuda has given me. For land, there are some for a picture, there's some green area, some blue areas, and some sand areas. Now I have to classify the amount of land is there from the picture. We all can understand the green one is the like forest ones or some trees are there, and there are some blue ones means the river is or some water body is there, and the yellow ones are the automatically. As a human, it is, I do not have to tell you. If I let you see a picture like that, you guys can automatically understand, but machine does not know it, or there is no one who will label it for him. Blue means this. So that's how it can automatically detect the similar blue kind of thing. What is the percentage of area? So what is the how many percentage of that particular picture given to me is water body? So someone say is claiming a tax waiver. I have a water body. I'm maintaining it. I want a tax waiver. As a thing, I fly a drone above him. Now I get that picture or heat map. So automatically I'll calculate how much of area is blue. So machine does not know it's a water or anything. There and supervision of that particular thing may not always be possible due to time, due to knowledge, or the same project right now I'm doing in Foxy Vision. There are lots of words. Not all it's not possible to take a Samsat dictionary and put it into my training set. It's not possible. It will take around 6 months. But I have to deploy it first. So at that time I will be using unsupervised. Always supervision is our very good friend. If I get a supervision, it's the best win-to-win-win situation. But it's not always that. Okay. So with the laptop, that's mostly what I do. Okay. Okay, Sumik, hi.
Hi, Son.
Okay, we have reached the end of the meeting.
Oh,
Uh, it, it was planned from 4:30, but it's okay. It's nonetheless, I can share you the PPT and we can discuss in the office sometimes later what I've talked.
okay.
Okay. Asif also has joined. Okay, so if no one is question, should I? Yeah.
So, when does that unsupervised learning works?
The unsupervised learning mostly works when there are data. I have to mostly classify or take a regressive kind of problem, or mainly unsupervised. I have seen so far in my practice is mostly classification kind of problem where no one knows. Because if I see a shape of the object, it is very trivial for me to group the similar kind of object. But in most of the data, those are some bunch of numbers. I do not know which number means what. So in that case, if I do not have proper domain knowledge or may not, I'm not a domain expert of a speech. Suppose if someone gives, there are lots of voice recordings and someone tell me classify male data and female data. And I am not a very expert because some male's voice can be very fine. Suppose someone is practicing everyday song rewatch and his voice will automatically be fine. Now I may be confused that this is a female voice, right? Or some female, maybe he has done something, his voice got a bit on the grumpier side. So how can I understand? I cannot label it. I don't have proper supervision. So in those cases, unsupervised are the best friends.
But
But
at the end, we have to level.
but suppose
Sorry.
in that case, machine can also make mistake, right?
Yeah, machines do make mistake, and
So
as they make mistake, our training gets final.
so in that case, then if machine does mistake, so
Hmm.
what is the how would you do that fine tuning for those
Okay,
mistakes?
so whenever there are how we measure in algorithms in terms of when we all whoever has heard of the term in case of normal algorithm, we call it time complexity. How we measure the performance of algorithms. In the same way, machine learning algorithms are mostly measured by the error rate, the amount of error it is making. Now, in the real life scenario, when I am deploying the model, it will make error. It will definitely make error. If I always count on those errors to more fine tuning, say it makes error. Now, a male voice is termed as female. So next time, my automatically unsupervised one will say, okay, my boundary is not perfect. So it will go a bit up and down on the dimension, vector dimension, and it will say, is this better? So it is automatically kind of, we can say, taking each thappar at a step and getting better.
Okay, but that no, no. I'm asking that who will define this that you are correct or you are wrong?
Okay, so whenever the ML data a model goes into the production, also the chat GPT asks us whether this response is good or bad. They always ask for our supervision.
That means that manual intervention is happening, right?
Yeah, we all have to collect data, and someone will always report that my YouTube suggestion, say I open a YouTube. So how the data error is rectified? The YouTube automatically suggests similar kind of videos to me. Now, if I scroll below, scrolling, means YouTube is taking into account that this particular user not liking my recommendation. So next time, whatever video he plays, it automatically knows my choice. Or maybe YouTube also very clever. At the time, say in the morning, I open my YouTube, I get a national anthem tomorrow. I will get definitely national anthem tomorrow. Or Lata Mangeshkar song. It knows. It also knows the date, time, and every behavior it takes. So by our own behavior, if I deploy a model, those errors are my friends always, because end of the day, those ML models will be used by normal user, and they will always train my model.
Okay.
Okay, Prosenjit got a question. I'll let me answer it. Okay, Prosenjit skip the question. Anyone else? Okay. Hopefully, no one has got a question. Okay. Should I
Okay.
end it? Subhadip wants to ask anything?
No, thank you.
Okay, thank you. Thank you, everyone. Okay, drop it.
Hello.